Hi, I'm Dr. Bruin and welcome back for part 14 of these commentary videos that sit alongside my A-level chemistry speedrun series. In this question, the first thing that we need to do is to think about the electron config of the two different ions, and I would always start by thinking about the atoms they're made from and then how you need to change that, because it just stops you from making mistakes. So firstly, this potassium, we've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, but of course potassium is in group 1, so when it forms an ion it does that by losing its outer shell 4s electron. So for the iron, we're going to take that one off. And then if we think about the chlorine atom that turns into the chloride ion, we're finishing up there with 3p5, but of course this is in group 7, so it's going to gain an electron. And so actually the ion is going to end up with the exact same electron configuration as the potassium ion. So we can describe these two ions as being isoelectric, or we could just say, well, actually they've got the same electron configuration. And that's important if we're going to think about which is going to be the bigger of the two ions. So although they've got the same electrons, they haven't got the same protons because they're different elements, and different elements are defined by the number of protons that they have. So potassium, of course, has an atomic number of 19, which means it has 19 protons, whereas chlorine has an atomic number of 17 and has 17 protons. So that means that the force that is generated by the nucleus, the electrostatic force, is going to be slightly stronger. So the electrons on the outer shell are going to experience a stronger attraction, but also crucially there's not going to be any additional shielding. So if we were thinking about maybe moving down group 1, going from sodium to potassium, there would be additional pull from the electrons, but there would also be additional shielding. There'd be a whole extra shell in there, and that's not what's happening here. So this means that the potassium ion is actually going to be smaller than the chloride ion, because those same electrons that started out in the same position, if you kind of think of it that way, are then being pulled closer to the nucleus by this stronger electrostatic force of attraction. Then in terms of the structure and bonding, the melting point of any ionic compound is going to be high because we've got this electrostatic force of attraction between the oppositely charged ions, and that is a very, very strong force, and therefore it takes a lot of energy to overcome it. Thanks very much for watching, and I hope you found this useful. If you did, then don't forget to like, subscribe, comment and share, and I'll see you soon for some more A-level chemistry.